Objective number 7 comes from section 14.4. It says, know what the 4 colligative properties are. Know if solute increases or decreases the process. Does it make it harder or easier? And be able to explain why. So freezing point depression. What does the word depression mean? It means down, yeah. You know, you're talking about mental or physical. Depression means down. A tongue depressor holds your tongue down, you know, for the doctor. So it means the freezing point goes down. So freezing point depression means freezing point gets lower when solute is added. So the question is why? Why does adding salt on the road make it harder for the ice to freeze? Yeah, there's salt in the way, and what are water particles trying to do to freeze? To freeze, water particles need to... What are the 2 things they have to do to go from a liquid to a solid? Not stop, but they have to slow down. And when they slow down, anytime particles slow down, what else happens? The particles move closer. So they move close enough that they take on a predictable shape or a rigid shape. So to freeze, water particles need to slow down and move closer. But solute will get in the way and make the whole process harder. And since the whole process is about losing energy, you'll have to lose even more energy. Okay, so I'll make the freezing point lower or colder. Some of you drive now, and you maybe haven't thought about this, but you use antifreeze in your car in the winter to keep the radiator from freezing, but you use the same antifreeze in the summer to keep it from boiling. I don't know why we call it antifreeze, because it's actually more often anti-boil. Far more often you need it to keep your radiator from boiling over than you do to keep it from freezing. But the same stuff works, because you put salt on the road to make it harder for it to freeze, but then when the water's trying to boil, basically the same thing's happening, but when you're trying to boil water, what are you trying to do to the water particles? You try to make them move faster and let them spread out. So freezing point elevation is just what it sounds like. It's higher. So it means the boiling point is higher. Alcohol will freeze. It just has to be really cold because it's got so little intermolecular force between it. There's no stickiness to it's got very low force of attraction. It's very slippery. I don't know what the actual freezing point is. I'd have to look it up. It can get cold enough in Minnesota to freeze alcohol, yeah. So to boil, water particles need to speed up and spread out. But again, the solute will get in the way. So since boiling requires a gain in energy, Okay, the other two we didn't talk about much in class, although I think I did a fabulous job on the video, and the book wasn't bad either. So what's vapor pressure? If you just had a guess based on the word, what would you guess vapor pressure means? It's the pressure of a vapor. Well, what's a vapor? It's water as a gas. Water as a gas is called vapor because at room temperature, water should be a liquid. There shouldn't be any water vapor in this room, if you think about it, because it's not 100 degrees Celsius in here. So when water is a gas at room temperature, it's considered a vapor. So vapor pressure is the pressure exerted by the water vapor. So if you add solute to your stuff you're boiling, we just said it's going to make it harder to boil. If it's harder to boil, are you going to have more vapor or less vapor? That's a lot to think about. If you add solute to your water, it's going to be harder for it to boil. So does that mean it's going to be got more vapor or less vapor produced? Should be less vapor, and if there's less vapor, there's less pressure. So that's why the first three tell you exactly what happened. You just have to be able to explain why, but they give you a hint what's happening. So vapor pressure lowering is because it's the pressure exerted by water vapor. After it leaves the liquid. It could be. I really don't know. I haven't looked at the test for a long time. I haven't corrected any, so I won't correct any until someone takes it tomorrow. So since less vapor is leaving, less pressure is produced. Okay, anybody remember from biology what osmotic pressure is? Osmosis? It's fluid moving across a membrane. Which way does it go? Does it go to where there's more solute or to where there's less solute? It goes to where there's more solute. It's trying to dilute it. It's trying to get things balanced. So osmotic pressure is the flow of solvent across a membrane flows from more solute, or from less solute to more solute. We put that down. It flows toward more solute. Or the other way you can think of it, or less solvent. It goes to where it's needed. Okay, and it'll continue to flow until the concentration is balanced on each side. That's why when you eat salty stuff, you have a lot of salt in what's called your extracellular fluid, the fluid around your cells. So then the water tends to flow out of your cells and make you dehydrated or thirsty. They also talk about people who, if you exercise for more than an hour and you're perspiring a lot, they say you should drink more than just water, because if you drink just water, so much water flows across your cells, it can actually make your cells start rupturing, which I think would be really painful. Just guessing. That's why they say you should drink some Gatorade to keep the flow balanced, so your cells don't blow up on you. So osmotic pressure, when you add solute to one side, is the pressure going to go up or down on that side? Up, because there's more solute, plus what else is going to happen when you add solute? The solvent's going to rush toward it. Yeah, so when you add solute to one side, solvent will flow that way.